Hi, I'm going to do an example about subnetting, and hopefully I'm going to be able to convince you that subnetting is a lot more simple than you might think, and that the root of all the confusion is all about the conversion from binary and back. So as an example, I got an IP address here and I have a /26. So what this does is it defines a subnet, and this is an IP address in the subnet. So first thing you want to do is, what's that? Well, that's 26. The subnet mask for this subnet is going to be 26 ones followed by filling up with the rest zeros. So here's what I mean. So I've got this IP address of /26, so the subnet mask is 26 ones and then the rest are zeros. So that's what that is right there. And to find out information about the subnet, you write the IP address beneath it in binary, and then you can learn all kinds of things about it. So the questions that they might ask on an exam might be the number of hosts. It might be the network address or the subnet address, and then the broadcast address. And really, what happens is if you have a subnet, what you're doing is you're dividing a network up into smaller pieces, and each piece is called a subnet, and there are a certain number of addresses available in the subnet. And the lowest one is called the network address, the highest one is called the broadcast address, and everything in between, all the addresses in between, are called hosts. So here's how we do it. You have the IP address, we've written it here in binary. The subnet mask is 26 ones followed by the rest zeros. Then I'm going to draw a little line here. And the subnet mask, what these ones mean is every bit on this side of the line, you can't move it. It has to stay exactly the way it is. And every bit over here, you can move it. So that means you can have all of this, right? So exactly the same, and then all zeros, 2, 3, 4, 5, 6. That's the lowest address in the subnet. And then, since we can't move these, keep this the same, and then 1, 2, 3, 4, 5, 6. The highest address would be all ones. So it turns out that this is all of this plus this is the network address, and all of this plus this is the broadcast address, lowest one, highest one, and everything in between, right? 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0. Count all the way up until you get here. Everything in between is a host. So that's it, quite simply. You write this in binary. You put the subnet mask on top of it, 26 ones followed by zeros. You draw a line where the ones stop and the zeros start. This part can't move. Make these all zeros. Network address, make them all ones. Broadcast address, everything in between is a host. Okay? So that's it. So then you can say network address is, it's all of that plus the zeros. So since this can't move, we can actually type this. This is actually 192. This is 168. This is binary for 2. And this whole thing is 64. So network address would be 192.168.2. Whatever that is. And it happens to be 64. Right? These can't move with all zeros. Broadcast address is, well, remember, these can't move. So it's 192.168.2, right? 192.168.2 dot 0, 1, 1, 1, 1, 1, 1, 1, 1. So what is that? 0, 1, 1, 2, 3, 4, 5, 6. Well, that is, what number is that? Well, that's 1 less than 1 with all these zeros, so 128, 120, 127. Is that what it is? I think that's what it is. So then from this all the way up to this, everything in between is hosts. It would be 192.168.2.65 up to .126. So there you go. That's that. And that's the simple way to do it. You convert this into binary, you put the subnet mask in binary, you draw the line here. These ones can't move, these ones can. All zeros is network address, all ones is broadcast address.